Yep. It's time to start.
For newables, anything that you can use to create an instance. Classes, of course, are probably the first thing we think of, right? So here we can say my date constructor is date constructor, and I'm going to take date, not new date, but literally date. Now I can do this. And this is date. This is now, this here, this is the interface of the class. So this is the constructor signature. I would say this is fairly rare. It's common, more common certainly to write call signatures, because anytime you have a callback, things like that, if you're writing higher order functions, you're going to end up with a call signature. But they're no more difficult. Just remember to add the new keyword. So another interesting thing that has to do with call signatures is a concept called function overloads. Let's imagine a scenario where we have a form, and maybe we have a central event listener, which is, as I understand, is best practice, right? So you don't have a bunch of different event listeners to set up and all those separate callbacks to maintain. You can have kind of a global event listener that dispatches events appropriately. And we want to handle events that could come from a form or an iframe. So with that, let's give it a shot, and let's think about the different types of handlers we would need. So a form submit handler takes form data as an argument. And a message handler, which would be like a post message channel, right? Where you're communicating with an iframe.
Let's check that out for a bit and see constructables and typescript. What was it? Constructables. Do we have that here? Do we have setdoc constructables? Yep. Now this is different. This is a library structure, but we're looking for constructables in TypeScript. Let's see what it is, so we're not just glossing over the materials. Okay, callables, yeah, yes. Funny enough, is this course? Funny enough, is here. Is this right? But I have the course already. Okay, let's look at the handbook. Yeah, classes. Go to the new page. Class, yes. Yes. Yeah. There's nothing here. Okay, they cannot be assigned to the field outside of the constructor. Nice. But we have something like this in the interface, where you create an interface date constructor and software type new date. Date constructor. We can use it to instantiate a class, right? The date constructor type. Okay. Oh, I see. For example, we have a date class, right? For example, we have a date class. We have we have a date class, right? Code, we have a date class. We have a date class. Let's see. So we have a date class. We have a date class. We have a date class. In that now what we did was we now created an interface. We created an interface date constructor, or let me call it my personal date constructor. Personal date constructor. Right. So I can say new and use what's happening here? Personal date constructor. Okay. And that is, we say new value. Okay. Okay, I need to disable Copilot. I don't want Copilot disable, right? Good. So if this is the case, so this is my personal constructor, I can say personal date constructor is equal to date, right? Okay. Const get time can now be equals const get time. I can now use the date constructor. I've already typed it. I can say const get time is now equals to new date, right? New date. New date dot. See, I have all the this is a constructible. Makes sense. So I have access to the instance of the class as well as I have. Oh, makes sense. That's nice. Actually, that's a good concept. Refreshing. Okay. That makes sense. Yeah, that makes sense. You can get time, you can get everything. Yeah. Okay, that's constructible. Yeah, we're talking about function overload.
You'd have this on message event, and you'd pass in something that looks like this. Like this is the type of message handler. So let's say we want to have a function that could handle both. That could, allow us to pass as one argument the element. The second argument is the type, and we kind of register those together somehow. So we can get an iframe. There's an HTML iframe element, and then we can call handle main event. And if we look at the type of val, well, it has an any type. And all right, well, I don't know. I kind of expected it to infer more here, but we can keep going. Because I think we get to the same place here. So I'll tell you what I expected to see. These are both single argument functions. They return void. So I kind of expected to see something like form data or message event as an argument with a void return type. But it seems to have failed, and this is now an implicit end. In either case, like we kind of
implicit any actually means impossible, right?
I pass in my form.
No, never. Yeah, never is what's impossible. Yes.
Element, and I get a form submit handler. Or I pass in my iframe element, and I get a message handler. We don't want to mix and match. We don't want like these two or these two here, right? We want to have one pair on the left or the pair on the right, and we can accomplish this with function overloads. So the way this works is we're going to create multiple function heads, we would call these. So the thing to note here is these are what we call function heads. They don't have a body. There's no implementation here. We're going to grab these two, and we're going to put them above what we would call the implementation of the function. And we'll need a return type here. All right, so if we look at how we're allowed to call this now, you see this 1 out of 2 and 2 out of 2. Look at that. First argument is a form element. Second argument is our form submit handler. And here's 2 out of 2. Got the iframe element and the message handler. So although the underlying implementation of this function would technically allow us to mix and match, right? They're just union types. There's nothing in this function itself that sort of expresses any relationship between the first and second arguments. What's happened is we've hidden this. This is not callable in and of itself. You can only call this function through one of these two heads. And so we've sort of limited the scope, the combinations of what can be done here. And so now this should be typed, and it is. There's a message event. But if I were to type in, we got a form. Look at that, it's form data. It switched on us. Because it knows you have to do one pair or the other pair. Sort of using the first argument to figure out the second argument. And you can think of it almost like when we call this function, it's going through the various function heads one by one to find one that matches like the first argument we're passing in, and then it'll try to find one that also matches the second argument, and then it'll let us use that. But if we were to delete this, for example, we could actually so now there's no iframe element here. If we were to switch back, this doesn't exist. You can't pass a frame in. If we were to look at this, it's just the form element. So you see how this implementation of the function, the last function head that has an actual, like this body here, we can't directly access that. We kind of only access it through the heads when we do this overloading technique. It is a really powerful idea, particularly because there are other ways of doing this that just are incredibly advanced in terms of types. This kind of makes an approach like what we're looking at here much more accessible without getting into generics where we have like types scribed in terms of other parameterized types. You don't want to be reaching for that unless it's important and necessary. One other thing I should mention here, the types of the heads, these being the heads, they have to align with the actual implementation here. So if we were to do this, we wouldn't be able to do this function head, right? So each of these parameters here, like each of the function types represented by the heads here, they have to fit within the underlying implementation. So once we add that back, we should be good. It's common, sometimes people even do this, and then they'll cast within the function implementation, knowing that they can sort of sort out what the type should be. You know, if you have like a wide range of things and you don't want to turn this into a crazy, expanded type. The reason it's somewhat a little bit safer here is no one can directly access this. Like you have a guarantee that if someone gets into this, they can't.
So I really understand what is being said here. Let's look at from data. function handler. Not a function handler. There was something we called it before, right? Callable. Yes, this is a callable using type. Yes, callable using type. Yeah, the type implementation for a callable. That's for where you describe the function. I think I can make sense of what's happening, right? Yeah, so we created a type. Yeah, we created a type for a function. We do it this way. Yes, this is exactly what we do. Yes. I think I understand what's happening here. Okay, and these functions can either take from submit handler or message handler. But if we move this now to the top, that's what's nice. Yes, when we move it to the top, then we are now experiencing function overload. Undo my frame. My frame type of HTML. Should be a return type. Should be a return type of void, right? That makes sense. It doesn't have a body. Makes sense. Yeah. Good. So undo main event. Undo main event. Nice. I think it makes sense.
So it's not the same as just having like an any out in the wild. Like you have some narrow set of pathways that someone must have taken to get into the function.
Is there a reason that we have to specify the types with a union instead of just letting it infer from the overload?
The TypeScript does not infer that way. So, I mean, that would be the reason. It's more that the type of the function itself is processed first, and then the heads are checked for compatibility with the underlying implementation. So I think it's sort of an order of operations issue where the real function comes first, and then the heads have to be compatible with that function. So the overloads, those heads don't really influence the type of the function itself. And it would also make it really kind of hard to maintain one of these if sort of the arguments would sort of get altered based on different signatures above. Like you want to get really tight about this being well typed, and then you can sort of constrain different usage patterns using the function heads. You wouldn't want to add another function head and then like everything inside the function lights up because like there's implicitly a new thing that could be there.
What is a construct signature in TypeScript? And how does it differ from a call signature? Let's go to the quiz and see. What is a construct signature in TypeScript? No. A construct signature is that. No. A type definition for creating instances using new keyword. Yeah, that's true. That's true. A type definition for creating instances. What is the purpose of a function overload in TypeScript? To create multiple implementation versions of a function, to reduce code complexity, to limit the possible. To limit the possible combination of arguments for a function. Yeah, that's closest to it, yes. To limit the possible combinations of a function. That's why you use function overload. So you are kind of, yeah, that's true. That's true. In function overload, what is a function head? A type declaration of parameters, the main implementation of a function, a method for type inference. Yes, it's a function signature without body. Yes, that's true. Yes. How do function overload works in TypeScript? By automatically inferring type argument, yes, by checking the various function signatures to find a matching type combination. Yes. What is the key constraint for function overload heads in TypeScript? They must have unique names. They require explicit type annotation. Yes, they must align and be compatible with underlining. Yes, they must align and be compatible with the underlining implementation. Yes.
All right. Part of functions is the concept of this, right? So if anyone's written something like a mouse click handler or a DOM event handler, you know that sometimes if you hook things up the vanilla JavaScript way with add event listener in a browser, this will be the DOM element that fired the event. So if we wanted to have a click handler like this and pass it a click event, we wanted to rely on this being something, like this being something. We need to provide it with a type. So here's a more involved example here. So here we're getting a button. We're literally getting the first button in a document, like in an HTML page. We can create a bound handler that tries to take my button and bind its context to undefined. Well, let's sort this piece out first. So what we're seeing here is that this cannot be depended on unless we provide it a specific thing. So what we'll want to do is the following. All right, it kind of looks like an argument. You might look at this and say, we just made a 2-argument function, but it disappears. This is still a 1-argument function. We're sort of using the arguments list as a place to put a type for this, but note, now we get the correct type here. So if you ever want to build functions that need a this to be a particular thing, outside the context of class methods where it's handled for you behind the scenes, this is what you're going to do. Note that if we just tried to invoke my click handler and pass it an event, this is not going to work. We don't have the correct this type. So this context of type void, there's void again. It's like, don't use this, ignore it. You shouldn't be sensitive to this, right? That's what void means here. It's telling us this is not safe. You shouldn't do this. You can't do this because you need to create the proper type. So what we're doing here is we're creating a button. We're then saying, I want to create a copy of my click handler, and I want to bind it to my button. Does everyone in here knows what bind is? So you're almost creating a copy of this function that's sort of packaged with a this applied to it, and now anybody can invoke this without worrying about what to set this to. It's just ready to go. So now we've created this new function here. Bound handler is of type any. Oh, this is a good little segue here. We're going to need to go to, you can do this with me here. We're going to need to go to the package.json. No, not the package.json, the tsconfig of this nodes project. So it's in the ts fundamentals v4 folder, get the tsconfig. So we've got no implicit this. That's why it was lighting up here before we added a type for this. And now we're going to add strict bind call apply. Set it to true. particular type. And if we look at the type of the click handler to begin with, see this piece? And now, when we have the bound handler, we've sort of taken the requirement for explicitly providing a this away. That's part of what bind does. So it's giving us a bound version of the function. Now, that lets us just directly invoke this function. This is already sort of glued to the bound handler copy of the function. Alternatively, we could invoke the original function, which still has a this type in it, and we could call it, but we have to pass it this button as the this. These are sort of like meta function, methods, like a way to, a way to invoke a function a different way. So if we were to open this up, you can see it's like, it's the menu that we provide an HTML button element. And that's what we need here. So it's only happy if we put in my button.
Nice.
It's kind of rare to deal with this types. If you're using them in a class, great. Where it becomes particularly important is like listening to DOM events. That's the most frequent case. Or if you're building like React components and you're kind of mixing like top level functions with methods, that's where like depending on which of those two you're choosing. One, the top level scope, like freestanding functions should not care about this. Methods already have the instance of the class as this.
Could you still call the function like on line 82 and pass a first argument?
You can't. When you invoke a function, like in this fashion, I'm trying to not use the word this in my explanations desperately, you don't get to explicitly provide a this. This dot call, like that's what you need. This is the way you would do this. Or function dot apply is another way of doing it. Apply, call, and bind are kind of ways to sort of apply and call are ways to invoke the function and pass it arguments, but also a this. Bind is the one that sort of bakes a this in to a copy of the function and gives you that copy, which at that point can be directly invoked, just like you see here.
Is there like something specific happening with the word this? Like if you change that first argument to just like element?
Very special.
Okay.
This is a special JavaScript concept.
Okay.
Not something TypeScript invented.
Okay, so but if you name that first argument just element, you could still say element dot disabled equals true, right?
Yeah, but that would require that you explicitly pass it in
Every time.
So you could do it like this. This is why you don't see it so frequently, because this is wider. And if we were to just move down out of the temporal dead zone, there you go. So it's almost like an implicit argument. This is why, like, if you're making a freestanding function, you want to do it that way. Now, if you're attaching an event listener to a DOM element, you don't really have a choice there. You can't tell a DOM element how to invoke your function. It has defined the way it invokes your function, and it will set a this. And if you want to write a TypeScript function that can take advantage of this, you will need to provide this type.
Nice. One more module and we'll be done. One more module. In TypeScript, how many? I can specify the type of a this in a function. Let's go in TypeScript. What is the purpose of specifying a this type in a function? We're correctly invoking it. What method can be used to invoke a function with an this is a bind, call and apply. When is specifying a this? What does the bind method do? Yeah, we can fix this. Yes. What is the significance of using void as a this type in TypeScript? Oh, indicate that the function should not use this. Interesting.
All right, the last thing I want to wrap up with here is just best practices for functions. So first, I have some good code in there. I do. This shouldn't be in here. Sorry, folks. Here's an example that illustrates like why having explicit return types is valuable. So let's say that we have a function as follows. And here we're sort of like awaiting a response to come back from the fetch that we're making. And then here we're saying like, okay, let's wait for the last byte of the response to come in, serialize it into JSON, so wait for all of that to happen, and get the data here, properties string array, and here we're going to load the data, which is calling this get data function. So like, what if we were to add a branch or a condition around this that said like, okay, I only want to wait for the data to come in and to return it if the response is okay. Like if I have a status code that is below 400, right? So I get an error here, says result is possibly undefined. And this is where I would say the error is popping up in the wrong place. It's not an ideal place for the error to pop up. Because imagine that get data is used in 100 places throughout a piece of code. And we just added that little change, and now like errors light up all over the place. We're going to have to go to those call sites and track down what's going on, figure out what's happening here. If we have an explicit return type, we could surface an error right at the declaration site. And what it would look like is the following. It's a promise, and we'll talk about this syntax in a bit. It's a promise that resolves to an object containing a properties field and a string. As you look down here, error is not popping up here anymore. So we're effectively saying we have an upfront commitment to return a particular thing, and we have not lived up to that commitment. And now we've got not 100 errors, we've got one error, and that one error is actionable. It's in the place where a fix needs to happen. I mean, if you wanted to intentionally return an undefined, I would advise that you explicitly state so here and then go and fix all of the call sites. But to me, this is a lot more useful, and it's why I sort of have a bias towards explicit function return types. I've just gone on a wild goose chase too many times, and this is just, regardless of what your preference is, I think there's a point where searching around for the source of the bug, like, there's a point where this kind of pays for itself, even if it looks ugly to you and feels like extra typing to provide.
Nice. What is the primary benefit of using explicit return types in type functions as well? Yeah, declaration side, that's true. Makes sense. Makes sense. In the example code, what condition was added? Is that it? Is it I didn't check? It's not if it's okay. That can be argued. What TypeScript feature helps identify potential undefined return? Explicit return annotation, yes. Let me start. What is the recommended approach if you explicitly state what problem does adding explicit return type help prevent a large code base?
The next topic we're going to talk about is classes. So hopefully you are familiar with classes as they exist in JavaScript. So you're familiar with the constructor, constructor function. This is what's called when you invoke a constructor and you say new car. We're building on our example of a car here by giving this class a make, model, and year. So in regular JavaScript, you might not see these, and you would, be able to kind of set these dynamically. You can just sort of drop properties on an instance. Because one of the goals of TypeScript is to have a defined shape for, any value that you're passing around, you have to define in some way class fields up front. And so this looks a little bit verbose, but you can see there's car.model, and then this is the model that comes in from the constructor. It looks verbose. I promise we're going to get to something a little bit later called param properties, which reduce some of the syntax down significantly. Here effectively we're seeing make, model, and year 3 times, in the parameters for the constructor, and then in the names of the class fields. Actually, it's 4 times, and then twice in each of these lines here. We'll trim that down so you see those words once each in a much more, abbreviated syntax.